So let's try to understand about the CAP theorem. So in CAP theorem, C stands for consistency, A for availability, and P for partition tolerance. So this theorem basically applies in the distributed systems. So this is mainly for the distributed system which is operating for more than one node. So any system you take which is operating in scale would definitely have more than one node. So essentially, practically this applies to any of the systems you are basically using in day-to-day life. So what this states that from consistency, availability and partition tolerance, you can only have always two in your system. And it is often misunderstood that you can take two of them, but usually when you have a distributed system, there will be always a partition tolerance. Partition tolerance is basically that two nodes uh, maybe sometimes cannot connect with each other. Maybe there is a power outage or some internet issues, but they're not able to communicate effectively at some point of time, but your overall system still remains intact and it is working fine. It means your overall system is partition tolerant. So you assume that there will be always partition tolerance into your system. So you can either take consistency or you choose availability, right? So let's try to understand with the examples, so it will be more clear at the end why I want to choose one over the other. So these are called CP systems, consistency and partition tolerance, and these are called AP systems, which is like availability and partition tolerance. So let's try to understand with the example. So as I said, this is mostly applied to a distributed system where you have more than one nodes. So let's take a simple example of distributed data storage, right? So you have two nodes, node 1 and 2, which is taking traffic for get and put. So put is basically to write and get is to read. So put basically puts a value with key 1 and value 1, and then get query tries to get that value with a key 1. Now if you have a distributed data stored, let's say put query goes into node 1, it writes it and it returns the success response to the client that hey, you have already written it, we are good to go. Now at the same time, or maybe a couple of seconds later, you do a get query, and maybe if it goes to node 2, then there'll be no data at node 2 because you have written in a node 1, right? So there is definitely a consistency problem. You have already written the data, but when you're trying to fetch it, because it is going to a different node, as this overall environment is a distributed environment, so you are not able to find the data, which is basically a consistency problem. So how would you solve the problem? Simple, that when you're writing into node 2, you also write into the node 2. Basically when a write query is coming to a node 1, you also do a write on node 2, and then only you return the success response, right? So now when the get query is coming, you get the data from node 2, or like it doesn't matter which node it comes to, it always return you the value, right? So that's a simple solution that you uh, ensure that whenever write is coming to a node, you write that data to all the nodes, so that subsequent get queries, if it falls to any of the other node, it will get the data. As simple as that. Now what is the problem with this solution? What happens is that always you cannot ensure that whenever write is coming, the node 1 is able to connect to all its subsequent nodes. So in this example, there is just one node, there could be like 100 of nodes. So it might happen that it's not able to connect to other nodes. So there is some network issues, so that is called partition tolerance. So it's not able to connect to other nodes. So in that case, you have two choices, right? Either you write to node 1 and return the success, or case 2 is, so case 1, write to node 1 and return success, or case 2 is you return failure because you're not able to connect to node 2, so you return failure to client that it's not able to write the data to any of the nodes. So maybe a client can retry or something like that. So what happens in case 1 is that there is a consistency problem, right? Which we discuss in the case 1, right? There is a consistency problem. In case 2, it's an availability problem, right? Because your whole system is not available. So that's what cap theorem is. In a distributed environment, there will be always a partition tolerance. So there will be always situations when node 1 is not able to connect to node 2, or node 2 is not able to connect to node 1, or vice versa, right? So in that cases, either you choose availability or you choose consistency. So that's what cap theorem says. So it's often misunderstood that you can choose any two of them, but partition tolerance would always be there in distributed environment. Always present in distributed environment. So in theory, you can say, okay, there is no partition tolerance, but the network is not always 100% reliable. So there will be situations when two nodes are not able to connect to each other. So in that case, you choose either availability or you choose consistency. So if you use consistency, then it is a case 2. Then if there is a write query and it is not able to replicate it to all the other nodes, then it just return for failure to the client and it says I'm not able to write at this point of time. So basically your system is not available, right? Other cases, you write to node 1, maybe it's not able to replicate that to other node, but you still just return the success because you have written it to one node, and eventually when the other nodes will come up, it will write it. But that's more of an issue with consistency. So here you choose availability over consistency, and here you choose consistency over availability. So what kind of systems you have for consistency, right? So mostly relational databases and RDBMS system come into these type of systems, and for AP mostly NoSQL like DynamoDB or MongoDB. So they prefer more of availability, and the RDBMS system more of prefer consistency over availability. So we already discussed about eventual consistent system, so let's try to understand in respect to cap theorem. So AP systems are mostly eventual consistent system. How? Because when you're doing a write query, because there was a network partition tolerance, uh, it, it writes it to node 1 and just return the success. It was not able to write it to node 2. So the read queries from node 2 might return you the stale data, right? But eventually this network partition, whenever it is resolved, maybe in couple of seconds or some after some minutes, the data would be synced with each other. So after some time, the read queries on node 2 will always also return fresh data. So that's where it's called eventual consistent, because after some point of time the data will become consistent with each other. But you cannot assume it to always consistent at any point of time. That's where it is called eventual consistent system, right? So that's what cap theorem states, that in a distributed environment there will be always a partition tolerance, or there would be always scenarios where one node is not able to connect with the other node. So in that case, either you choose consistency or you choose availability. So in case you choose consistency, you have to give away availability. In cases you choose availability, you have to give consistency for some time, right? So that's what is there, that when availability is chosen over consistency, the system will always process the client request and try to return the most recent value of the information, even if it cannot guarantee it is up to date due to network partition, right? So here you are choosing availability over consistency. So it's not guaranteed that you always get the most recent version of the information, right? So this is more of a eventual consistent system. So consistency over partition tolerance, when consistency is preferred over availability, the system will return a timeout, right? It simply says, okay, I'm not able to write it to all the other nodes, so I just return the error. So in that case, for clients, your system is unavailable, right? But it will always ensure consistency. So such type of systems are mostly like relational databases, where you are mostly dealing with transactional data and other things. So database system with asset guarantees are mostly the follow the consistency over availability and design, and the systems which are designed with base guarantees choose availability over consistency. So these are like DynamoDB or NoSQL databases, right? So that's all about uh, cap theorem. Uh, Thank you.